Hello students. Last presentation we had discussed on working substance, pure substance, thermodynamic system, types of system, comparison between open system, closed system and isolated system. So today we will discuss on intensive property and extensive property, point function, path function, flow and non-flow process, specific volume, temperature, density, pressure, enthalpy, entropy, then work, energy and heat. Intensive property. The property do not depends upon mass of the system are known as a intensive property. Example, pressure, temperature, density. Extensive property. The property which depends on the mass of the system are known as a extensive property. Example, enthalpy, entropy, total volume. Point function. They depends on the state only and not on how a system reached that state. I will explain you basis on the diagram. In figure, the system undergoes a changes from a point A to B. These changes can take place via path A or path B. Hence, a property does not depend on the path, so it is point function. Path function. Their magnitude depends on the path followed during a process as well as end state. I will explain you basis on the diagram. System is undergoing a change from state 1 to state 2. This change depends on intermediate state through which system change its condition from point 1 to 2. System can change its state by two paths, that is path A and path B as shown in figure. Work transfer can be represented by area under a PV diagram and work transfer path function. It will be different from path A and path B. Work transfer for path A is more than work transfer for path B. Therefore, work transfer depends on path of system and is called path function. Flow process. The process occurring in open system which permit the transfer of mass to and from the system are known as a flow process. Let us see the example of turbine. In this process, mass enter in the system and leaves after enhancing energy, which means that such process occur in the system having open boundary permitting mass interaction across the system boundary. Non-flow process. The process occurring in closed system which do not permit the transfer of mass of across their boundary are known as a flow process. Example, piston cylinder arrangement. In this system, energy cross the system boundary in a form of heat and work, but there is no mass into or out of the system. See some basic definition and unit. Specific volume. It is defined as volume per unit mass is known as a specific volume. Unit meter to cube per kg. Density. It is defined as mass per unit volume is known as a density. Unit kg per meter cube. Volume. It is defined as the amount of space that a substance or steam occupied. Unit meter cube or centimeter cube. Temperature. It is defined as measure of ability of system to transfer energy by conduction or radiation process. Means it is measure of hotness or coldness of the body. Unit Celsius or Kelvin. Kelvin is equal to Celsius plus 273. Means to convert a Celsius to Kelvin, we need to add a 273 to the Celsius value. Hence, the result derived would be the Kelvin. For example, if I want to convert a 10 degree Celsius to Kelvin, I will add 273 to 10, that is 273 plus 10 is equal to 283. Hence 10 degree Celsius equal to 283 Kelvin. Pressure. It is defined as force exerted against per unit area. Unit Newton per meter square. Enthalpy. It is defined as energy which algebraic sum of internal energy and flow of work. Unit kilojoule per kg. Entropy. It is thermodynamic properties of system which increase with addition of heat and decrease with removal of heat. Work. It is defined as the energy transfer without transfer of mass across the boundary. Means the energy can cross the boundary of the closed system in a form of heat and work. Therefore, if the energy crossing the boundary of closed system is not heat, it must be work. Energy. It is capacity to do work. In our syllabus, three types of energy: kinetic energy, potential energy, and internal energy. Kinetic energy. Kinetic energy, the energy created from the motion of mass. Formula half mv square. M means mass, v means velocity. Potential energy. Potential energy, the energy due to position and elevation of mass with respect to earth's surface. Formula mgh. M means mass, g gravity, h height. Internal energy. Internal energy, it is property consisting of combined molecular, kinetic and potential energy. Heat, it is energy interaction between the system and surrounding due to temperature difference. Means heat energy transfer from one system to another only by reason of temperature difference between the systems. Heat exists only as it crosses the boundary of the system, and direction of heat transfer is from of higher temperature to lower temperature. In this diagram, heat transfer from higher to lower. So direction of heat transfer is higher to lower. For thermodynamics sign convention, heat received by the system is positive, heat rejected by system is negative, as shown in figure. Thank you.